Alright, so here we have a little energy problem, and I'll read it first. A baseball player throws a baseball straight up in the air with an initial velocity of 20 meters per second. Using what you know about conservation of energy, find the highest point that the ball will reach. Assume there is no air resistance. So the first thing that we're going to have to do is we are going to have to define what is in the system. So my approach to do this problem was to have the baseball player, the ball, and the earth be in the system. So this way there's no work done on the baseball because the arm is in the system, and that is going to be, when the ball is thrown, it's going to be kinetic energy. And then since the earth is in the system, we can have gravitational potential energy. So I don't know how to make a bar chart on Microsoft Word. So from problems we've done, I know that kinetic energy is going to be equal to the gravitational potential energy, the final gravitational potential energy, and kinetic energy is equal to 1/2 times mass times velocity squared, and gravitational potential energy is equal to mgh. So this means that mgh equals 1/2 mv squared. So now you guys might be thinking that we don't have the mass and we need the mass, but since the mass is on both sides and it is the same, that means that the mass will cancel out. So we're going to have the force of the Earth, the acceleration of the Earth, which is 9.81 meters per second squared. I know it's squared, but I don't really want to put the squared. Oh, I could do it like this. Times the height, which is what we're trying to find, equals velocity squared over 2. Velocity is 20 meters per second, so we'll put that in. So that is 9.81, or 9.8, 9.8 h equals, and 20 times 20 is 400. 400 divided by 2 is 200. So that's meters squared per second squared. But yeah, I'll just write it meters per second. But you guys know, and I know. So then we do 200 divided by 9.8 is 20.41. And that should be our final answer.